Inside the core of the Sun, the temperature reaches nearly 15 million degrees Celsius. Here, hydrogen atoms are crushed so tightly that they fuse together. This process is called nuclear fusion, and it powers our star. During fusion, 4 hydrogen nuclei combine into one helium nucleus. A tiny amount of mass disappears, and that lost mass becomes pure energy released as a photon, a particle of light. But this photon is far from free. The Sun's core is incredibly dense, like trying to swim through solid crowd. The photon is absorbed, re-emitted, and scattered millions of times. Even though light travels at 300,000 kilometers per second, this constant scattering slows its progress. It may take thousands to millions of years for a single photon to escape from the Sun's center. The journey of light begins not as a straight beam, but as a long struggle through the heart of a star. After its chaotic birth, the photon begins its slow outward movement through the Sun. The first region it enters is the radiative zone. Here, atoms are tightly packed. The photon travels only a fraction of a millimeter before colliding with another particle, getting absorbed and re-emitted in a new direction. This random zigzag motion is known as a random walk. Eventually, the photon reaches the convective zone. This layer behaves more like boiling water. Hot plasma rises, cools, sinks, and rises again. Instead of scattering, energy is carried upward through the motion of matter itself. Finally, the photon reaches the photosphere, the layer we recognize as the Sun's surface. From here, for the first time, the photon is no longer trapped. It can now travel freely into space. After millions of years inside the Sun, the photon leaves in an instant as sunlight. Once the photon escapes the Sun, the environment changes completely. Space is nearly empty, no atoms to block its path. For the first time, the photon travels in a straight line. Light moves at the ultimate speed limit of the universe, 300,000 kilometers per second. At this speed, the photon crosses 150 million kilometers, the distance from the Sun to Earth, in just 8 minutes and 20 seconds. And during this journey, the photon behaves in a deeply mysterious way. It acts both like a particle and a wave. This strange duality is a foundation of quantum physics. The same photon that struggled for ages inside the Sun now races effortlessly through the vast emptiness of space. When the photon reaches Earth, it encounters one of biology's most extraordinary optical systems, the human eye. The photon first passes through the cornea, a transparent curved surface that bends light. This bending is called refraction. Next, it travels through the pupil, which expands or shrinks depending on light levels. Then it reaches the lens, which adjusts its shape to focus the photon precisely onto the retina. The retina contains millions of tiny light-sensitive cells called rods and cones. Rods detect brightness. Cones detect color. When a photon strikes one of these cells, it triggers a chemical change that converts light into an electrical signal. A photon that began in the core of the Sun has now become information. The electrical signal travels from the retina through the optic nerve toward the back of the brain. It reaches the visual cortex, the part of your brain that interprets visual information. Here, the brain performs extraordinary processing. It assembles signals into shapes. It adds color. It judges distance and motion. Only after this complex reconstruction do you become aware of what you are seeing. You do not see light itself. You see your brain's interpretation of that light. The photon's journey is complete. From nuclear fusion in the Sun, through space into the eye, processed by the brain, becoming vision. Every moment of sight is powered by energy born inside a star.